Plutonium is the most radioactive and destructive material ever created by humans. And this is not an exaggeration. With just a few grams, it can trigger a massive nuclear explosion and endanger an entire country. But how is it possible that such a small metal holds such power? Where does this devastating material come from? Well, today we will travel to South Carolina, United States, home to one of the most protected nuclear facilities in the world. Savannah River, a place where every day, tons of nuclear waste are transformed into plutonium oxide, ready to fuel reactors, manufacture powerful weapons, or be stored under maximum security in secret government facilities. So get ready, because you are about to discover how the most dangerous material on the planet is mass-produced. It all starts with the key ingredient to create plutonium, uranium-238, a highly radioactive and dangerously precious element. This metal is found buried hundreds of meters underground, trapped inside a black rock called uranite. To extract it, a colossal mining operation is needed: giant excavators, hydraulic shovels weighing hundreds of tons, and monstrous trucks transporting tons of radioactive materials under strict safety protocols. And here is the astonishing part: in every ton of rock, there are only a few useful grams. In fact, it takes more than 500 tons of ore to obtain a single kilo of workable uranium. And although this may seem small, this kilo, once processed, can generate enough plutonium to power a nuclear reactor for decades or to make several atomic bombs. Once extracted, the ore is transported to the processing plant. There it is pulverized and mixed with extremely reactive chemical solutions until a dense yellow paste known as Yellowcake is obtained. And although its name sounds harmless, this substance holds the potential to destroy entire cities if it falls into the wrong hands. This whole process takes place under extreme security measures. Any leak or mistake could contaminate the soil and water, rendering an entire region uninhabitable for centuries, as happened in Chernobyl. It is only when the uranium is refined, stabilized, and secured that the green light is given for the next step in creating the most feared material on the planet. Here begins one of the most delicate and critical phases of the entire nuclear process. In specialized facilities, tons of yellowcake are introduced into huge chemical tanks filled with acid where they dissolve under extremely controlled conditions. The goal is clear: to eliminate all remaining impurities and isolate the purest possible uranium. Once dissolved, the liquid passes through calcination furnaces where it is completely dried and subjected to temperatures exceeding 500 degrees Celsius. The result is a dense black powder known as uranium dioxide, a stable, highly concentrated compound with the exact purity level needed to initiate its transformation into plutonium. To help you understand, it's as if the yellowcake had been processed to the perfect point to continue its process. Then, this powder is compacted into small cylindrical pellets or thin rods using industrial presses. A perfect design for its next destination: the active core of a nuclear reactor where everything is about to change. With thousands of uranium dioxide pellets already prepared, the key moment has arrived, initiating their transformation into plutonium. The rods containing these pellets are carefully inserted into the core of massive nuclear reactors. There it remains completely submerged under tons of ultrapure water, which serves a dual vital function: cooling the system and acting as a radiation barrier. What happens inside this reactor is invisible to the naked eye, but it's one of the most powerful transformations in nature. For weeks, the rods are bombarded by neutrons in an invisible process called nuclear transmutation. The uranium-238 atoms gradually begin to mutate into plutonium-239, one of the most destructive and rarest materials known. To give you an idea, just 1 gram of plutonium produced at this stage can release more energy than several tons of coal or oil. But this conversion is not without risk. Any deviation, however slight, could trigger a nuclear disaster. That's why everything is monitored 24 hours a day, with automated sensors, steel shielding, and highly specialized personnel. Finally, after weeks of irradiation, the rods are extracted. They now contain latent plutonium inside and are ready to move to the next step toward the most dangerous form of energy that exists. Once removed from the reactor, the irradiated rods are literally heated to red hot. They have just undergone weeks of nuclear bombardment and now contain an extremely dangerous mixture of uranium, plutonium, and intense radiation. In this state, handling them directly would be a deadly hazard for operators. That's why the next step is to cool them down in a controlled and safe manner. The bars are immediately transferred to enormous cooling pools, with reinforced concrete walls over 2 meters thick and extreme monitoring systems. There, under more than 5 meters of ultrapure water, the rods remain completely submerged for several months. But it's not just a cold bath. This is a critical stage known as radioactive decay, where the material gradually releases accumulated radiation, reducing its danger so it can be handled afterward. It is only when all parameters are completely stabilized that the extraction of the water rods is allowed. And then comes the moment to separate the pure plutonium from the rest of the nuclear waste. We reach the most dangerous moment of the entire process. The irradiated rods, already cooled and stabilized, are introduced into an automated cutting system that breaks them into small metal segments. Next, these solid fragments go through a chemical circuit where they are dissolved in concentrated nitric acid at over 100 degrees. The result? A thick and radioactive mixture, a chaotic cocktail of uranium, plutonium, and unstable nuclear waste, literally the most dangerous liquid that exists. And this is precisely where one of the most advanced chemical techniques in nuclear engineering comes into play, the PUREX process. This system uses special solvents that separate plutonium atom by atom, leaving behind the rest of the contaminated material. It's like searching for gold nuggets in a sea of toxic debris, except this gold can power nuclear reactors for decades or destroy entire cities in seconds. That said, the plutonium obtained is not a bright green liquid like in the movies. In reality, it is a dense, yellowish liquid so radioactive that even brief contact with human skin would mean certain death. If all goes well, the result is pure plutonium in its rawest form, ready to finally be converted into the material we need. We now have pure plutonium, but in its liquid state, this material is so unstable that minimal exposure to air could trigger an immediate nuclear emergency. The next step is to transform it into a safer and easier-to-handle form. Plutonium oxide, a solid, compact, and slightly more stable substance, although it remains one of the most lethal compounds on the planet. Everything takes place in airtight and shielded laboratories, where what technicians call a true atomic baking begins. First, the liquid plutonium is dried at extreme temperatures, then it is condensed, and finally it turns into a dark powder, similar to volcanic ash. Once stabilized, this powder is introduced into precision industrial presses which compress it again until forming small cylindrical pellets the size of a coin. These pellets, known as pellets, are now the final plutonium. Small, compact, and lethal, and their destination can mark the difference between technological advancement or the end of humanity. We arrive at the most secret and most important stage of the entire process, deciding what to do with the plutonium. The plutonium oxide, already transformed into small cylindrical pellets, is now under extreme surveillance, protected as one of the most dangerous and valuable materials on the planet. From this point, the path can take two completely opposite directions. On one side, the most stable pellets are sealed in armored capsules and sent to civilian nuclear reactors, where they will be used as high-efficiency fuel. There, the plutonium generates clean energy, capable of lighting hospitals, powering entire cities, or keeping industries running for decades. But the other path is much darker. The pellets selected for military purposes are transported in ultra-secret convoys, escorted by special forces to classified government facilities. There they are refined, processed, and converted into active cores for nuclear warheads, the most feared weapon ever created by mankind. To give you an idea, only 9 countries worldwide possess enough military plutonium to manufacture nuclear weapons, including the United States, Russia, and China. And it is precisely these countries that dominate the global balance of power. Because plutonium is not just a material, it is a statement of absolute power, a resource capable of lighting the planet or wiping it off the map in seconds. After seeing all this, a truly troubling question arises. Is plutonium an indispensable scientific achievement or a human madness we no longer control? Some will say it is the price to pay for energy and power. Others that it is a material that should never have existed. Which side are you on? Say it clearly in the comments. If you like this documentary, then don't forget to like, subscribe, and activate the bell so you don't miss any of our content.